Hello students, in this video we are going to discuss about solar cell. We already know what is a solar cell. It is a device which converts light energy to electrical energy. In our school itself we have a solar panel, a large solar panel, and all our computer systems are working with solar energy. And it is a green fuel because it does not require any petrol or diesel, it does not require any fossil fuel, it does not have any emission, zero emission. So it is a clean energy. Therefore we are always telling people to use solar energy for all our needs. So let us see how a solar cell works. So the principle of solar cell, these photovoltaic devices convert optical radiation into electricity. It will directly convert optical energy to electricity. So this is the picture, a P side and N side, it is a PN junction diode, and there is a provision for that the light to fall at the junction. And you can see there is no battery connected. We don't require any extra cell or any extra battery for the solar cell to work. It will directly take the sunlight, and because of the energy of the sunlight, electrons and holes are generated and electrical energy is formed. So if I study the thing in detail, it consists of a large surface area. Look at here, look at the second figure. There you can see the surface is very large. There is a thin N layer and P layer is below the N layer. The N layer is very thin. Because it is the first layer, it should be thin, so that light should pass through the N layer and reaches the junction. The energy of the light has to be absorbed at the PN junction only. That is why the N layer is made thinner. So that light should pass through the N layer and reaches the junction. And you can see on the top surface, you can see certain blue lines. Those are actually metal contacts. They are finger shaped metal contacts. So they will collect the electrons formed and all the electrons will reach at this point. Similarly, below the P side there are also certain electrodes kept. They will collect the holes and it will reach at the bottom point. Okay, so this is the picture of a PN junction diode. So it is marked here metallized finger electrons. They will collect all the charges and all the charges will reach at this terminal. Okay. Now, when solar light, sunlight falls on a PN junction, it generates an EMF. So how that EMF is produced? As the solar radiation is incident at the junction area is kept as much as larger for more power generation. On the other side of the P layer is coated with a metal. This serves as a back contact. So on the top there are finger electrodes, and at the bottom it serves as a back contact. The bottom of the P layer is coated with a metal which serves as a back contact. The top N silicon layer, metallic grid is deposited. This is called front contact. That is what I call finger type metallic electrodes. The light is incident on the grid from the top, and when light incident, what will happen? How does it work? The generation of EMF by the solar cell is due to three basic steps. The generation of EMF by the solar cell is due to the following three basic process. The first one is generation, the second one is separation, and third one is collection. Generation, separation and collection. Generation. Generation of electron hole pairs due to the light with energy H nu greater than Eg. Okay, so this is electron hole pair, generation of electron hole pair due to the light with energy H nu greater than Eg. This is how you should write. Okay, so generation of electron hole pair due to the light with energy H nu greater than Eg close to the junction. So what happens is, if light strikes the PN junction, if the energy is greater than the band gap, electron hole pairs are formed, because covalent bond at the junction will break and electrons and holes are formed in the junction. Now the separation of electrons and holes due to the electric field of the depletion region. The electrons are swept to the N side and holes to the P side. That is called separation. So I will tell you, when the light comes and strikes at the junction, if the energy H nu is greater than Eg, electron hole pairs are formed. Electrons will move towards the N side and holes will move towards the P side. That is called separation. Electrons will move towards the N side and holes will move towards the P side. So it will create a potential difference, right? It will create a potential difference. Now the electrons reaching the N side are collected by the front contact and holes reaching the P side are collected by the back contact. Thus P side becomes positive and N side becomes negative, giving rise to photovoltage. So this much is understood. Electrons are collected over the N side, holes are connected over the P side, thereby creating a potential difference. So it will give rise to a photovoltage. Now if we connect an external load, or if I connect an external resistor, then what will happen? When an external load is connected, a photo current will flow through the load. That means if I connect any small external resistor, the current will flow through that. Now just see the graph. The VI graph of the photodiode is in the fourth quadrant. Here I have marked open circuit voltage and here I have marked short circuit current. The VI graph is in the fourth quadrant. Why the VI graph is in the fourth quadrant? It is because solar cell does not draw any current from the circuit, because for its driving it does not need any external power source. Solar cell does not draw any current from the circuit, it generates and gives the current to the circuit. That is why the graph is in the fourth quadrant. So they can ask a question, why the VI graph is in the fourth quadrant? Solar cell does not draw any current from the circuit, it gives the current to the circuit. That is why the graph is in the fourth quadrant. Okay. So you can just write down this. Now if I take a single solar cell, the energy produced by a single solar cell is very less. So we have to connect many solar cells together to form a solar panel. Each solar cell can produce a voltage from 0.7 volt to 1 volt. One solar cell can produce only 1 volt. So if I need 50 volt, I need 50 solar cells together to form a solar panel. So that is why in our school you can see many solar panels are kept. They can provide energy up to like 100 kilowatts. Okay, so that much big panel system we have. What are the applications of solar cell? They are used in power electronic devices in satellites and space vehicles. Space vehicles we don't have any other electrical source. So they will directly take the sunlight and they will convert sunlight into electrical energy. They are also used in power supply in calculators. We have seen solar calculators and we have solar watches and Solar street lights are there nowadays. So it does not require any electricity. You can directly take sunlight and convert it into electrical energy. So solar street lights are there, solar calculators are there. Now, what are the criteria for the material for selection of solar cell? The first criteria is the band gap is between 1 electron volt and 1.8 electron volt. The material that we are choosing, it should be 1 electron volt to 1.8 electron volt. Number 2, the material should have high optical absorption. Number 3, it should have high electrical conductivity. And number 4, availability of the raw materials. And number 5, cost effective. So we are using special grade silicon. We can't use normal silicon, we use special grade silicon which is having high optical absorptive power. So the cost of solar cell is a little bit higher. And also in between, the connections in between the solar cell to make the solar panel, there we are using silver. So that also adds up the cost. So those are the important points, those are the important criteria, and you have to think one more thing. The material having band gap about 1.5 electron volt is the ideal material for making solar cell, because that will be having high optical absorption and it can convert energy, the light energy to electrical energy. So the band gap should be between 1 to 1.8 electron volt, but the ideal material is having band gap of 1.5 electron volts. Okay. Now what are the advantages of solar cell? Number 1, I already told you, it is pollution free. It will not emit any harmful gases. It is pollution free and it is long lasting and maintenance free. Pollution free, long lasting, maintenance free. That is why everybody is motivating us to use solar cell. Okay, so that's all about solar cell. So with this, our chapter Semiconductor Electronics comes to an end. Thank you.